In this video, we're going to talk a little bit about some facts concerning continuity. And these first 5 facts may remind you of some of the facts about limits. And there's a good reason, and that's because continuity, the definition of continuity, is all tied up with limits. So anyway, let's look at these. Suppose f and g are functions that are continuous at x equals c. Then the following functions are also continuous at x equals c. F plus g, f minus g, f times g, f divided by g, again provided that the denominator here is not 0, so that g of c is not 0. So those should remind you of some of those rules with limits. And then if you multiply a continuous function f by any real number, the result is still continuous. Before we go any farther, we need to talk about a definition. We're going to define the concept of polynomial. So let n be a non-negative integer, so 1, 2, 3, 4, 5, and so on. Then any function of the form p of x equals c sub 0 plus c sub 1 times x plus c sub 2 times x squared, and so on, up through c sub n x to the n, where each of those c's, those ci's, is a real number, and the last one, cn, is not 0, is called a polynomial of degree n. So what's allowed in a polynomial? You can have a constant term, you can have a constant times x, a constant times x squared, and so on and so on. The highest power that actually appears, that doesn't disappear because the coefficient 0, that highest power is called the degree of the polynomial. So let's look at some examples and determine whether they are polynomials or not. So in these 4 examples, you're asked to determine whether the functions are polynomials, and for any polynomial you are asked to find the degree. Alright, so number 1, you've got y equals 3x minus 7. Is this a polynomial? Yes, it is. And the degree is the highest power on x that appears. The degree is 1. What about the second one? Is it a polynomial? It is not. Why not? Because of this term. This is the same thing as x to the 1/2. The square root of x is the same thing as x to the 1/2, and you're not allowed to have fractional exponents. The only exponents you can have are positive integers. Well, non-zero, non-negative integers. You can have 0. What about number 3? You've got 4x cubed minus x plus 9. Is it a polynomial? Yes. It's a polynomial of degree 3. What about number 4? You've got h of x equals 5x to the 7th power plus 2x minus 3 divided by x squared. Well, you can rewrite this as 5x to the 7th plus 2x minus 3 times x to the minus 2. You've got that negative exponent. It is not a polynomial, just like number 2. Alright, here's a nice fact. A polynomial is everywhere continuous. A polynomial does not have a single discontinuity. And why should that be? Well, first of all, the function f of x equals x is continuous everywhere, right? That's just a line, looks kind of like that, passes through the origin with slope 1. Now, any power of x is just going to be, well, for instance, x squared is x times x. Well, remember that if you multiply a continuous function by another continuous function, the result is continuous. So x squared is continuous. Now you can multiply that by x and get x cubed. That's continuous. Well, you can multiply these things by constants, and you will still have continuous functions that are continuous everywhere. And then you can add them together or subtract them, and you'll still have continuous functions. So everything you can do to form a polynomial is something that preserves that continuity. Let's talk about one more definition. A rational function is a function that can be written in the form p of x over q of x, where p of x and q of x are each polynomials. So a rational function is just a polynomial divided by a polynomial. Now, the numerator in a rational function is continuous everywhere. The denominator is continuous everywhere. So the result of the division, p of x divided by q of x, should be continuous everywhere, except where the denominator is 0, because that's going to make the rational function undefined. And that's our next fact, that a rational function is continuous everywhere except for values that make the denominator 0. So in this example, you're asked to find all the discontinuities of the function. It's a rational function. The numerator is x squared plus x minus 6, and the denominator is x squared minus 3x plus 2. Well, since it's a rational function, you know that it's going to be continuous everywhere except for values of x that make the denominator 0. So what we need to do is factor that denominator, or at least set the denominator equal to 0 and solve. Alright, so x squared minus 3x plus 2 equals 0. You've got a quadratic equation, and it's one that's relatively easy to solve using the method of factoring. It factors into x minus 2 times x minus 1. And then we set each factor equal to 0. X equals 2 and x equals 1 are the solutions. And so those are the discontinuities of that function, x equals 2 and x equals 1. Notice I did not factor the numerator or do any canceling. All I did was I set the denominator equal to 0 and solved. Those are the two discontinuities. The function is continuous for all other values of x.